Okay, guys, here's your helpful hint video for this week's FRQs. Okay, so I believe this is the one from page 72. We're doing A and D. For part A, I'm not going to really give you many more hints. I'm saying that's just what we've been doing that a lot. We want to approximate or estimate the instantaneous rate of change of C at 3.5. So we pick the points that are closest to it. As for part D, let's go ahead and take a look at that. The amount of coffee in the cup in ounces is modeled by the function you see there. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So if you're looking for a rate of change, that means you're looking for the derivative of it, right? So let's go ahead and do that. I'll go ahead and we don't really need the table for this because they give us a function instead. So they're asking us to find basically b prime of 5. So you need to find the derivative of that function. Okay. So if b of t is equal to 16 minus 16 e to the negative 0.4t, gotta find b prime. Derivative of 16 is gone, and then you have negative 16 e to the negative 0.4t times the derivative of this, which is negative 0.4t. That's a chain rule. And then basically you plug in 5. So this may have been a calculator active question. So I think we can go ahead and use our calculator on this one to get the answer. But that's basically all you would need to do. They're going to want some units, however. But even if this wasn't a calculator active question, we could just leave it like this because, you know, that's the answer, right? You don't have to simplify it. And as far as the units go, it was, what were those units? It was, get rid of this object here. It was ounces and minutes, right? So it's this many ounces per minute. There you go. So let's go ahead and move on to the next FRQ there. For this particular FRQ on page 76, I don't think I'm going to be needing to give you guys any helpful hints here. It's pretty clear. It's giving you a position function and you're being asked to find the acceleration at a specific time. Just make sure that your units are correct. Let's go ahead and take a look at the next one. The next one on page 112 of your book, we're going to be doing A and B. Now with A, they want you to find whether the speed is increasing or decreasing at t equals 2. Excuse me. If you want to know whether speed is increasing or decreasing, you need to find both velocity and acceleration at t equals 2 and compare the signs. Now they're going to want an explanation why or why not. Okay, so let's go ahead and see what we can figure out here. This is question 2. So first of all, I want you guys to understand this is a calculator active question. Now, if you remember your derivatives pretty good, I think you guys probably could find the derivative of this by hand. However, I think that that's going to be a little bit more work than is necessary. So what I want to do is I want to remind you guys how to do this on a graphing calculator. All right, so first of all, let's just review the strategy. We want to find velocity and acceleration at t equals 2. To find velocity, we just need to plug in 2 into this function. And honestly, we could probably do this by hand. It probably wouldn't be too bad, but we're going to go ahead and just use a calculator. And we're also going to find acceleration. Now, something that's important to understand here is that acceleration is the derivative of velocity. Okay, so the acceleration is going to be equal to v prime of t. Okay, so we need to find out what v of 2 is by just plugging in here. And then we also need to find out what v prime of 2 is. And since this is a calculator active question, great opportunity to review how to do things on the calculator. So that's what we're going to do now. Now, I'm not going to do this problem for you. I want you guys to do it, but I'll show you how to do one that's similar to it, right? So let's say that I had a function, right? And I told you that my function was, you know, x squared minus 4x, right? And we wanted to find f of 1. How would we do that? Okay, I know you guys could just plug it in by hand, but I want to show you how to do it in the calculator so that you can do your FRQ. So the first thing we do is we go ahead and turn on our calculator. We push x squared, and then we push minus 4x, and then we're going to push, go back to the home screen, second quit. We're going to go to variables, y variables, functions, y1, parentheses, and we're going to plug in 1, and that will tell us what our function equals at that. So that would be my answer for f of 1. But what if I wanted to find f prime of 1? This is something we haven't done in a little while. So what do we do here? We're going to push math. Actually, I think the way you guys are probably most familiar with it is through the graphing approach. So let's get out of there. Let's go ahead and just push graph, and it's going to graph the function for us. Okay, and I want to find the derivative at 1. So we push second calc, and we go down to the derivative button, which is 6. And then we're going to type in the x value they want us to find the derivative at, which is 1. And there it is, it's negative 2. Now, in this case, if I was calling this first one a velocity, then the derivative would be its acceleration, right? And since these are the same sign, I would say that it's speeding up. Okay, so that's kind of how you're going to handle your question as you type it into your calculator. Some of you guys still don't have calculators probably, but you can always get some of them as an app on your phone for a pretty decent amount, sometimes even free. Sometimes there's even free ones online. You guys really need to get one, and you definitely want to stop putting that off. But there it is. So I'm going to leave that with you guys. Okay, guys, as for your next FRQ, I think what I assigned to you guys was part C. Pretty similar to the last problem we did, so I'm going to go ahead and... Now, here's the thing about this one. On this one, though, what's different is this is question 6, and it's always like the first 1, 2, or 3 questions on the FRQ that are calculator-based. Question 6, like 4, 5, and 6, those are almost never calculator-based questions. So this is something that you would want to do by hand. Okay, so I'm going to go ahead and let you guys handle that. But it's very much like the last problem. You just can't use a calculator. You actually use your old school derivatives and all that good stuff. All right, let's move on to the next one. And for this one, which is on page 114 in your book, we're doing A, B, and D. We're being asked to find the acceleration. What they're giving us in this problem is the velocity. And as we mentioned before, acceleration is really just the derivative of the velocity. So we want to find v prime of 2. Okay. Now, what's the pain in the butt here is the fact that you're being asked to find the derivative of this expression. So I'll go ahead and I'll help you guys out with that, but I'll let you guys do the rest after that. Okay. So the rule for arctangent is, if you want to take the derivative of it, that is, it's 1 over 1 plus x squared, okay, times the derivative of whatever your x is, but we don't really have something here. Now, on our problem we're looking at here, what we have then is the following. It's going to be 1 over, well, I guess we'll say v prime of t, the derivative, right? The 1 goes away. We have a negative, so we want to keep that. and the derivative of arctangent is 1 over 1 plus the inside function there, e of t squared, times the derivative of the inside, which is e of t. Okay, so a nice simple way to write that would be negative e to the t over 1 plus e to the 2t. Okay, and they want you to find the acceleration, which I'm pretty sure you guys will be able to handle at this point now. This is question 3, so whether or not it's a calculator question is kind of up in the air, but even if it's not a calculator question, you guys can tell pretty easily whether it's positive or negative, and kind of get your context from that if you need to. Because in part B, we're going to be wanting to know, is the speed of the particle increasing or decreasing at t equals 2? So we know we're going to plug in 2 here. My guess is it probably is a calculator question, so I would just go ahead and use the calculator, because I don't know, plugging in e squared into arctangent is pretty wild. I'm guessing that would probably be it. Go ahead and just use your calculators. But let's go ahead and see part D. Find the position of the particle. Oh, I'm not giving you guys part D. You guys can ignore part D, sorry. Okay, and as for your guys' last one, we've seen this question a couple times already. Is the particle's speed increasing or decreasing at t equals 5.5? This is definitely a calculator question for 2 reasons. One is it's question 1. That's always a calculator question. Second of all, these are some pretty crazy looking functions, so to ask you guys to do, you know, the derivatives and stuff with that's kind of a nightmare. And they're also asking to plug in decimals, so definitely going to be using a calculator here. So just use the skill I showed you back there on that previous FRQ, how to use the calculator to get your velocity and to get your acceleration, and from there you should be able to find out whether it's increasing or decreasing. Okay, just so you guys know, you'll want to look at how they grade this thing. Notice they find the velocity at 5.5, they find the acceleration at 5.5. They are asking you to give a reason for your answer. Here's how you would write your reason for your answer. The speed is increasing because velocity and acceleration have the same sign. That's how you would explain it. Okay.